video we are going to revise the NCERT first chapter for class ninth, matter in our surroundings. So we just only revising the chapter, we will not go in detail. So the what we have, a matter is something which have both mass and volumes, and everything in the universe is made up of matters. Okay, a Indian philosopher divided matter into five basic elements, which is like Panchatattva they call it, and air, earth, fire, sky, and water. Then modern scientists have divided matter into on the basis of the physical and chemical properties. And let's discuss about the physical properties. Okay, they did an experiment where they concluded that matters is made of small particles. A few crystals of the potassium permanganate can color a large volume of water, about 100,000 liter. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. This experiment was done, and it was concluded that the matter is made of small particles, characteristic particles in matter. And then we have now discuss about the states of matter. The in India, the matter was divided into five categories, which are Panchatattva, and also in modern science we have also five categories. We mostly gonna discuss three: solid, liquid, gas, and there are two also, like, which is hardly visible and on Earth, and we will also discuss that later. So first discuss about the solid state. Solids have a tendency to maintain their shape when subjected to the outside force. So what happens in a solid, as a matter is made of constant particles. In solid, the constant particles are so close that they cannot move. So this is why this is solid, and they have a fixed definite volume and shape. And in liquid, the constant particles are there is just some distance between the constant particles, and they can freely move. And thus we may conclude that the solid, liquid, gases can diffuse into the liquids. And there is a gaseous state. In this state, the constant particles are very far, and their movement is, their particles movement around the surroundings is comparatively very fast than the liquid state. So smell of the hot cooked food reaches us in second, compared to this with the rate of diffusion with the solid and liquid. So by the hot cooked food, there is a gaseous state. So in gaseous state, the particles can travel very far. That is why the smell of hot cooked food is reaching us very in seconds. Due to the high speed of the particle and large space between them, the gases shows the property of diffusing very fast into another. So diffusing means like spreading a random movement, and so that is why this the gas diffuses very fast, because the particles doesn't have any force of attraction between them, and they are separated very far from each others. So there is also pictorial representation in solids. There is that the constant particles are intact, they cannot move. Liquids, they can move, but comparative to solids. But in gaseous state, the particles are very far, and they vibrate and move randomly every time. Now we talks about, can we change the state of matter? We can we have a two we have to study now. We change the state of, we can change the state of matters by, with the effect of temperature. When we increase the temperature of a liquid, temperature for H2O, State changes: solid, liquid, gas. Okay, ice, ice, liquid, and gas. On increasing on increasing the temperature of the solids, kinetic energy of the particles increases. Due to the increase in the kinetic energy, the particles start vibrating with a greater speed. The energy supplied by heat overcome the force of attraction between the particles. The particles have their fixed position and start moving more freely. The particle leaves their fixed position and start moving. So so when we heat anything, when we giving energy to the particles, and they first overcome the force of attraction between the particles, and also their kinetic energy increases. And then if the kinetic energy increases, they start doing random movement. So the melting point of a solid is an indication of a strength of the force of interaction between the particles. Force of interaction between the particles. If the force of interaction is a more, that means the melting point will be high, and vice versa. Change of solid state into liquid state is also known as diffusion. When the solid melts, its temperature remains the same. So where does the heat goes? Where does the heat go? This heat is used up in changing the state by overcoming the force of attraction between the particles. As the heat is absorbed by the ice without showing any rise in the temperature, it is considered that it gets hidden into the content of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as latent heat of diffusion. So the particles in the water at 0 degrees Celsius have more energy as compared to the particles of same temperature. Particles in ice and same temperature. So why it is? Because of the when we heated the ice and we give it energy, and we the energy is uh, used in breaking the uh, attraction force between the particles, and also its kinetic energy increases. So that means more energy compared to the particles of ice means more kinetic energy. When you supply heat into water, the particles start moving faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. This is also happens how solids while heating converts into liquid, and liquids again on heating converts into vapor, which is a gaseous state. No, not vapor, sorry, not a vapor, but into a it evaporates and becomes gaseous state. Evaporation is something else. We will discuss this later. That is water vapor at water va- that is water vapor at 100 degrees Celsius have more energy than the water is uh, have more energy than the water at the same temperature. This is because the particles in steam have absorbed extra energy in the form of latent heat of vaporization. So like water vapors, and see there is a difference between vaporization and the boiling. See there's a we will discuss the vaporization here in below in this chapter. It is defined in different way. Effect of change of pressure. So we discussed earlier that the matter state can be changed by change in temperature. Now we're gonna discuss we can change by giving it pressure. The difference in a varied state of a matter is due to the difference between the distance between the constant particles. So if the constant particles are close, they are solids. There are some distances, they are liquid, and they are very far, and this is gaseous state. So this difference can be managed by applying a pressure. Do you think that increasing or decreasing pressure can change the state of matter? Yes, it can. So this is a pictorial representation is there, and the piston is there, and uh, at first the particles are very far, and piston we down, and the particles get compressed, and it come closer, forms liquid state, and when it is compressed further, and the particles get intact and form solid state. uh, Solid carbon dioxide. Do you have heard of solid carbon dioxide? It also stores under the high pressure. Solid CO2 gets converted directly to gaseous state. Solid carbon dioxide is also known as a dry ice. Now discuss about this solids into liquids. This is fusion, and liquids to gas vaporization, gas to solid deposition, and liquid to solid is solidification. It's simple. And gas to liquid condensation, and solid to gas is sublimation. Solid to gas, we have a one example like a camphor is one example, and dry ice is another example, which they convert directly from solids to gas. Now evaporation, let's discuss this. We know that the particles of a matter are always moving and are never at rest. At a given temperature, in any gas, liquid, or solid, there are particles with a different amount of kinetic energy. Okay. In this phenomenon, the change of liquid into the vapor at any temperature is below the boiling point is called temperature. This phenomena of change of liquid into vapors at any temperature below its boiling point is called evaporation. So see, it's water boils at 100 degrees Celsius. Okay, and when it boils, so it forms it evaporates, and then become gas. Okay, it boils and become gaseous state. But in evaporation we cannot say like evaporation is like when the liquid states, when the change of liquid state into vapor at any temperature below its boiling point. So it below its boiling point, below 100 degrees Celsius, if the water converts into vapor, this is called vaporization. Factors affecting vaporization is there. We want to only discuss the important points which may come in examination. Humidity is amount of water vapor present in the air. Water vapor present in the air. An increase in the wind speed. It is a common observation that clouds dry faster in windy day. How does the evaporation causes cooling? In an open vessel, liquid keeps on evaporating. The particles of the liquid absorb energy from surrounding to regain the lost energy during evaporation. The particle of the liquid absorb energy from surrounding to regain the lost energy during evaporation. This absorption of energy from the surrounding make the surrounding cold. So let's understand with this one example. Okay, what happens when you pour some acetone, a nail polish remover, on your palm? The particle gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. So what is happening? Like here, uh, they are taking like temperature from surrounding, heat from the surrounding, and that is why we feel cool. They gain energy means they need heat. They are taking heat from our palm or from our surrounding, and that is why our palm and surrounding feels cool. There is another question: Why should we wear cotton clothes in summer? During summer, we perspire, it's sweating. We sweat more because of the mechanism of our body which keeps us cool. It's about the summer. Why should we wear cotton clothes? Do you know that during the evaporation, the particles at the surface of liquid gain energy from surrounding or body of the surface to change into vapor? The heat energy equal to latent heat of vaporization is absorbed from the body, leaving the body cool. So this is an important thing. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton being a good absorber of water helps the absorbing the sweat and exposing it to the atmosphere for easy evaporation. So what is the main idea is like cotton is uh, cotton absorbs water, and what happens is water has a good latent energy, and then it takes energy from surroundings to get evaporated. When it will get energy from our surrounding, the surrounding will get cooler. So this is why wearing cotton clothes make our body and surrounding cooler, because it will absorb heat energy from our body. So now there is another one. Why do we see water droplets on the outer surface of the glass containing ice cold water? Ice cold water. This is very simple. The water vapor present in the air on coming in the contact with the cold glass of water loses energy and gets converted into liquid states, which we see as a water droplets. So it depends upon temperature. If the gas molecules, see, if the molecules are very far, that means they have a high kinetic energy. If they come closer, they lose energy. If they come before the surface of ice, they will lose energy, and the kinetic energy, they will lose kinetic energy and they will come closer. Okay, this is the scenario where the constant particles are far. This is gaseous state. Now the constant particles are closer. This is liquid state, and this is why the gaseous states converts into liquid state. And now we have discussed all three forms of like matter there, solid, liquid, gas. There is another two one which I already told you we're gonna discuss. Fourth one is plasma. Plasma consists of a super energetic and super excited particles. Super energetic and super excited particles in the form of ionized gas. Gases, fluorescent tube and neon sign bulb consist of plasma. The plasma is created in the star because of high temperature, very high temperature. And another one is last state of matter, which we know is the Bose-Einstein condensate. Indian scientist and German scientist. Bose-Einstein condensate is formed by cooling a gas of extremely low density, about 100,000 of density of normal air, to super cool temperature. So this is the end of the chapter, and what we have learned, we're gonna discuss this. Um, the matter is made of small particles. The matter around us exists in three states. Around us, okay. There are also two more states which are not exist usually exist around us, usually do not exist. The force of attraction between the particles are maximum in the solids, intermediate in liquids, and minimum in gases. The space in between the constant particles and the kinetic energy of the particles are minimum in case of solids, intermediate in liquid, and maximum in gases. And by increasing or decreasing the kinetic energy and constant and distance between the constant particles, we can change the state of the matters, solid, liquid, gas, like we discussed above. There are two ways to do it: by regulating temperature and pressure. By doing this, we can increase or decrease the distance between the constant particles and increase or decrease the kinetic energy of the particles. The arrangement of particles is most ordered in case of solid. In case of liquids, layers of particles can slip and slide over each other, while in gases there is no order. Particles just move about random. The state of matter are interconvertible. The state of matter can be changed by changing temperature or pressure, as I discussed just before. The sublimation is the change of the solid state directly to gaseous state without going through the liquid state. Deposition is opposite to sublimation. Deposition, where the gaseous state directly converts into solid state. No liquid state is there. Boiling is a bulk phenomena. Particles from the bulk hole of the liquid changes into vapor state. This is a boiling. And evaporation is a surface phenomena. See, boiling is a bulk phenomena. Suppose something is boiled and everything is boiling. That means the whole content of liquid is vaporizing. And in evaporation is only surface phenomena. What happens in the sea? What happens in a glass of water left for a long time on heat? So suppose yeah, sea water evaporates due to evaporation. This is surface phenomena. Only sun rays gets into the top layer of the water, and their kinetic energy increases. The molecule of kinetic energy of the S2 increases and they evaporates. Evaporation is a surface phenomena. Particles from the surface gains enough energy to overcome the forces of attraction present in the liquid and change into vapor. The rate of evaporation depends on the surface area exposed to the atmosphere, the temperature, the humidity and the wind speed. Evaporation causes cooling. This is an important concept. Evaporation causes cooling. Why? Because in evaporation, like, particles absorbs heat energy to overcome the force of attraction between the constant particles. If the heat it gains heat there, and the surrounding gets cooler. And we already discussed the cotton example. So evaporation causes cooling. This is a Let me highlight this. Now, the latent heat of vaporization is a heat energy required to change 1 kg of liquid to gas at atmosphere pressure at its boiling point. Let's read it again. The latent heat of vaporization is a heat required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point. Latent heat of fusion is amount of heat energy required to change 1 kg of solid into liquid at its melting point. So see, it's about latent heat of diffusion and latent heat of vaporization. This is all about like how much energy is needed to break the intermolecular uh, attraction force, so that the particle overcome the attraction force, and their kinetic energy increases. So this is what the latent heat is about. And we have some units. Temperature is Kelvin, length for meter, mass kilogram, weight Newton, volume cubic meter, density kilogram per cubic meter, and pressure is Pascal. We have some exercise. Convert the following temperature. So this is exercise. Okay, temperature to Celsius scale. So this is Kelvin scales, and in Celsius scale, like we have to minus it by 273.15. Convert the following into Kelvin scale. We have to add 273.15. Okay, in both, give the region of the following observation. Naphthalene ball disappears with time without leaving any solid. Without leaving any solid. So why? Because this directly converts into gaseous state. Solid to gaseous state directly converts. That is why this is the reason. Can you get the smell of perfume sitting several meters away? Yeah, we can. And why? Because in the gaseous state, the particles like move randomly at a very far speed. So the particles of the smell, which is a gaseous state, moves randomly, and that is why they can reach a longer distances. Arrange the following substances. Arrange the following substances in an increasing order of the forces of attraction between the particles. So forces of attraction will be most oxygen, sugar, and water. Oxygen is a gas, the lowest. Sugar is solid, and water is liquid. So sugar have sugar will be the first. Increasing order, na. Increasing order means increasing order force of attraction. Okay, first will come oxygen, then we water, and then highest sugar. It's just like it is gas, it is solid, it is a water. What is the physical state of water at? It is a liquid, it is a solid, and it is a gas. Give two reasons to justify. Water at room temperature is liquid because room temperature is around 37 degrees Celsius, and I can't remember the second reason. Okay, an iron almirah is a solid at room temperature. Iron almirah is a solid at room temperature. Iron has a high melting point, and its room temperature about 37 degrees Celsius. So it is a solid because you know the force of attraction between the particles is very strong, and just 37 degrees Celsius cannot break these inter inter these interaction forces. Why is the ice a retina 273 Kelvin is more effective in cooling than the water at the same temperature. Why the acid is more effective in cooling than water at the same temperature? So it is, I think, because ice being a solid, it needs more energy. The constituent particles are close to each other, so and there is a inter attraction force between the particles is more. So more attraction force is required, that means it more attraction force is there, that means more heat energy it will required. If more heat energy it will absorb, the surrounding will be more cooler. And what in case of water it is comparatively less, because the already the particles, there is a space between the constant particles and they needs less heat energy for overcoming the attraction force. If it takes less heat energy, then the surrounding will be less cooler compared to in case of solids. So the answer is about uh, the energy which is required to overcome the attraction force. We need more in case of ice and solids and less in case of liquid. What produces more what produces more severe burns? Boiling water on hot steam? I think its answer is hot steam, but steam, but I don't know exact reason for that. Name ABCDF in the following diagram. Change in state. Okay. Solids to liquid, it is fusion. Liquid to gas, evaporation. Gas to liquid, liquidification or condensation. And then liquid to solid, solidification. Then solid to gas is like sublimation, and gas to solid is deposition. Okay, there is a group activity. Thanks for watching this end of the chapter.